Okay, in this current series of videos, I've been looking at topics dealing with the derivative. I've gone over some formulas for finding the derivative of a function, in particular the quotient rule and the product rule, along with the basic formulas. I've looked at one application. In this video, I'm going to look at the idea of critical number of a function, that is, finding the critical numbers of a function. So here's a definition. If a number c is in the domain of a function f, then c is said to be a critical number of f, provided the derivative at c is 0 or the derivative c does not exist. That is, it's not defined. Now, right now we're just going to go through how to find the critical numbers, and then later we'll look at what you can use these critical numbers for. So here's a definition. Critical numbers then have to be in the domain of the function, and we want those values for which the derivative is 0 or the derivative does not exist. Okay, so the obvious thing to do then, in the first example, we have find the critical numbers of the given functions, is to find the derivative. Okay, so using our basic formula, we can find the derivative of this function. We're just going to equal to 2x. That is, the derivative of x squared is 2x. The derivative of minus 2x is minus 2. And the derivative of minus 6, that's a constant, is 0. Okay, so the definition of a critical number is those numbers for which the derivative is 0. So you can see that this right here, if you set this equal to 0 and solve it for x, you get x is equal to 1. So x equal to 1 is a critical value of the function. That's where the derivative is 0. Now this is a polynomial, so polynomial is defined for all real numbers. If you take the derivative of a polynomial, you get another polynomial. So the derivative will always be defined. So we don't have to worry about the case where the derivative is not defined. Now, if I go ahead and evaluate the function at 1, put a 1 over here in the function, 1 there, and a 1 there. I get 1 minus 2 is minus 1, and a minus 6 is minus 7. So I get this point right here, which is 1 minus 7. Now this is referred to as a critical point. Okay, so here we're just finding the critical numbers. So x equal to 1 is a critical number, and 1 and negative 7 is what is called a critical point. Now let's look at the graph of this so you can see what this involves. So I take my graphing calculator over here, and I'm going to graph this function. So it's y is equal to x squared minus 2x minus 6. And then I'm going to go to zoom, and I'm going to do a z standard. And it's a nice parabola here. Okay, so the point 1, negative 7, if I were to plot this, I would go 1 over here and then go 7 units, and this would be this point right here. So this would be the low point of the graph. So actually this would be what is called the minimum value. Negative 7 is the minimum value of this particular function. Notice if I go to the table, I can confirm that when x is equal to 1, y is negative 7. So that's the minimum value. So there's my critical point. Okay, so x equal 1 is a critical number, and then the minimum value of this function is negative 7. Okay, that's the smallest value, so sometimes we refer to this as a relative minimum. Now I also want to look at this aspect here. In the last video I looked at the finding the equation of the tangent line to a curve. So notice in this particular case, if I were to go, let's say, look to the left of this point right here, if I were to draw, say, tangent lines along this side over here, they would be in this direction, this way. those lines would have a negative slope. So the derivative would be negative. Whereas if I go to the right of this minimum point here, the tangent line goes this direction. Those type of lines have a positive slope. So here the tangent line would be positive, slope over here, and so forth. So this would tell me then that if I have a critical point and the derivative to the left of that is negative and the derivative to the right is positive, this would suggest then that the curve is falling. Negative slope means the curve is decreasing, falling, and a positive slope based on what I have here indicates that the graph is rising. So the graph reaches a low point. So we're going down and go up. So it reaches what we call a relative minimum. Okay. Now if this had looked the other way, okay, so let's suppose the graph went like this over here. Then over here, my critical point would be right here, right at the top here. So the tangent lines to the left would have a positive slope. The tangent lines to the right would go down this way. The slope would be negative. So again, a positive slope means the curve is rising. A negative slope means it's decreasing. Okay, so that's one way we can locate. Using the critical value, we can determine whether the function reaches a high point, which would be a relative maximum, or a low point, which would be a relative minimum. This one is a rational function. So in this case, I'd have to use the quotient rule, which I went over in the last video. So I would take the derivative here. So this would be c prime t. So the quotient rule, if you have a rational function, you find the derivative, the formula tells me that the derivative will have in the denominator the square of what's over here in the function. Okay, so it's t squared plus 25 quantity squared. Okay, then in the numerator, it's going to be what you have in the denominator in the original function, which is t squared plus 25 times the derivative of what's in the numerator. The derivative of 50t would be 50. Okay, let me draw this a little bit longer here. And this will be minus then. Okay, I'm just using the quotient rule. So then I have minus what's in the numerator of the original function, which is 50t. Times the derivative of what's in the denominator. The derivative of t squared is 2t, and the derivative of constant is 0, so this is just giving me 2t. Okay, so then this is going to equal to so what I have in the denominator, t squared plus 25 quantity squared. And in the numerator then I'm going to have this 50 times t squared would be 50t squared, and then this over here would be 2t times minus 50t would be a negative 100 t squared, and a 50t squared is minus 50. So this will be minus 50. T squared, and then plus 25 times 50, which will be 1250. Okay, so there's my derivative. So again, I apologize for the writing if you can't make it out, but this is what I have. I have here minus 50 t squared plus 1,250 over quantity t squared plus 25, and then that's squared. Okay, so now we're finding critical numbers. So the critical numbers, again, are numbers for which the derivative is 0 or undefined. Okay, obviously if you have a rational function, it's going to be undefined if there's numbers in the denominator, or if there's numbers that make the denominator 0. Well, t squared plus 25, there's no real numbers that's going to make that 0. So the only critical number we can have then is whatever makes the fraction 0. So the fraction is 0 when the numerator is 0. So we take this and set it equal to 0. So I'm going to say, okay, this is equal to 0. So I would have, okay, I want to find out when is this quantity 0 right here. So it's minus 50 t squared plus 1250. Minus 50 t squared plus 1250. Set it equal to 0. So to find the value of t, then I would go ahead and bring this over to this side. Okay, so just look at the numerator, because that's all I'm concerned with. What makes that 0? So it's not like I'm looking at the equation. Minus 50 t squared plus 1250 is equal to 0. So if I bring this over, I would get minus 50 t squared plus, minus 50 t squared is equal to a negative 1250. Well, I would divide both sides by negative 50. So that would lead to this equation, t squared then, or I should say 50 t squared is equal to, and this will be a negative, to a negative 1250. Okay, and then I would just divide through by negative 50. So t squared then would equal to 25. Okay, so I solve for t, so that would tell me then take plus or minus the square root, and t can equal to a negative 5 or a positive 5. Now these are the critical numbers. T is negative 5 or 5. And this would correspond again to points, values for which the function reaches a high, a maximum, or a minimum. Okay, so if I wanted to find the critical points, then I would go, this would be 5. And then I would plug in 5 into this function. So put a 5 here where the t is 5 times 50. A 5 here, this 5 squared is 25. And then divide that out, and I get 5. So the point 5,5 is a critical point. I would do the same thing with the negative 5. Okay, put a negative right there, and this will give me a negative 5. Okay, so the point 5,5 and the point negative 5, and negative 5 are the critical points. And again, this is where the function can reach a maximum or a minimum. So if we were to look at the graph of this, okay, so let's look at the graph. So this would be 50. I use x instead of t, doesn't matter. Divide by, this would be x squared plus 25. And again, I'll do a zoom, z standard. Okay, so this is what we have. So right here, if I go 5 units over, then I would go 5 units up, and that's where it reaches a maximum. We'll call it relative maximum. If I go 5 units in the negative direction over here, and then 5 units down, that would be your minimum. And you can check this out with the table here. Say at 5, it goes to 5. And at -5, it goes to -5. Okay, so that corresponds, like I said, to this point here and this point, the point 5, 5, and over here the point -5, -5. Okay, so these are your. This is the procedure then for finding the critical numbers. And like I said, using the critical numbers, you can determine or use critical numbers to sketch the graph of curves to find, like I said, relative maximum and relative minimum values. And there's other applications that are going to follow later in the next videos. So please stay tuned and please subscribe if these videos are helping you. We'll see you next time.